The legend of the Bermuda Triangle, or the Devil's Triangle, encompasses a vast stretch of the western North Atlantic Ocean, conventionally bounded by points connecting Bermuda, Puerto Rico, and Miami, Florida. This area gained its mythical status due to an alleged disproportionately high number of inexplicable losses of ships and aircraft, often cited as vanishing without a trace. While the exact coordinates are disputed, the area covers some of the deepest oceanic regions in the world, including the Puerto Rico Trench, which further complicates any efforts to recover wreckage and lends credence to the idea of complete and mysterious disappearance. Early accounts contributing to the area's notoriety include logs from Christopher Columbus's first voyage in 1492, where he reported sightings of a great fire falling into the sea and erratic compass behavior. Though these events are now widely attributed to meteors and natural magnetic variation, respectively. The modern sensationalized myth began to take shape in the post-World War II era, coinciding with a massive increase in maritime and aviation traffic across the vital routes connecting the Americas and Europe. The event that most profoundly cemented the triangle's place in popular culture was the disappearance of Flight 19 on December 5, 1945, a routine navigation training flight of 5 U.S. Navy TBM Avenger torpedo bombers. The flight commander reported experiencing complete disorientation and failure of both his primary and secondary compasses, suggesting that they were encountering an unknown phenomenon that rendered conventional navigation impossible. Compounding the mystery, a large PBM Mariner flighting boat sent out to search for Flight 19 also vanished, its loss perhaps attributable to a sudden explosion due to a known design flaw related to fuel vapor, though this fact is often omitted in popular accounts. The absence of wreckage from either Flight 19 or the rescue plane became a central pillar of the supernatural theories, leading writers like Charles Berlitz to speculate wildly about phenomena ranging from remnants of the lost civilization of Atlantis interfering with technology to abductions by UFOs or inexplicable dimensional vortices. These highly speculative theories rely heavily on the fallacy of selective reporting, emphasizing cases where a clear explanation is immediately unavailable, while ignoring the vast majority of incidents that were fully solved and attributed to mechanical failure, rough seas, or simple human error. The scientific and statistical evidence, however, offers a far more prosaic yet geographically compelling explanation for the high rate of accidents. The U.S. Coast Guard and marine insurance experts, notably Lloyd's of London, maintain that statistics do not indicate that the Bermuda Triangle is any more dangerous than any other heavily traveled sea region globally. The perception of danger is skewed simply because the area is one of the most trafficked marine arteries in the world, connecting the Caribbean, the Americas, and Europe, thus inevitably leading to a high absolute number of incidents over centuries. The natural environment plays a critical role, primarily through the Gulf Stream, a powerful, swift, and warm ocean current that flows through the triangle. The Gulf Stream rapidly shifts, exacerbating weather conditions, producing sudden violent squalls and massive waves, and most importantly, acting as a massive conveyor belt that quickly disperses and carries away any debris or wreckage from a sinking vessel or downed aircraft, contributing directly to the without-a-trace mystery. This strong current, combined with the extreme bathymetry, the proximity of shallow continental shelves to the very deep Puerto Rico Trench, makes recovery operations incredibly complex, often leading search teams to abandon efforts, which is then reported as an unexplained vanishing. A particularly fascinating and plausible geological theory concerns the phenomenon of methane gas hydrates trapped beneath the continental shelves within the triangle's boundaries. These hydrates, formed under high pressure and low temperatures, can suddenly decompose and release massive bubbles of methane gas that rush to the surface. If a ship were to sail directly over such an immense eruption of gas, the sudden decrease in water density beneath the hull would cause the vessel to lose buoyancy instantly and sink within moments, potentially offering no time for a distress call.
While this theory is difficult to prove definitively due to the ephemeral nature of the gas release, it offers a solid scientific explanation for the sudden and complete loss narrative frequently cited in the triangle's lore. Furthermore, the region is frequently subject to rapidly developing and extremely violent weather, including hurricanes and tropical storms, especially during the Atlantic hurricane season. Many of the most famous disappearances occurred in small, non-weatherized vessels or older aircraft lacking the modern weather avoidance technology such as advanced radar and satellite weather tracking that is now standard, making them acutely vulnerable to sudden meteorological disasters that could down them before they could radio for help or transmit a final position. The human element, encompassing navigational errors, inexperience, and recklessness, remains the primary factor in maritime and aviation loss globally, and the Bermuda Triangle is no exception to this persistent reality.
The enduring global interest in the Bermuda Triangle also serves as a case study in confirmation bias and the creation of folk history. Once the narrative of a mysterious region was established in the mid-20th century by authors like Vincent Gaddis and Charles Berlitz, every subsequent unsolved or poorly documented disappearance within that loosely defined area was immediately categorized as triangle evidence, while similar losses occurring outside the boundaries were ignored or attributed solely to natural causes. This selective aggregation of data created an illusory pattern of risk. Furthermore, much of the sensationalism relies on obscuring the fact that many of the vessels lost were small pleasure craft, inadequately equipped for sudden oceanic squalls, often captained by inexperienced navigators unfamiliar with the local hazards, including the unpredictable formation of rogue waves and the strong, shifting currents near the Florida Keys and the Bahamas. These factors, common to coastal areas globally, become mysteries only when they occur within the arbitrarily drawn borders of the triangle. A closer technical examination of the methane hydrate theory reveals its specific relevance to the no-trace element of the Bermuda Triangle myth. These hydrates, ice-like structures composed of water molecules trapping methane gas, are extremely common under the seafloor globally, but their release mechanism is particularly relevant here. Geologists hypothesize that geological events, such as underwater landslides or tectonic activity, could destabilize vast hydrate fields, causing them to rapidly sublimate from solid ice into gaseous bubbles. The ensuing eruption of gas would not just slightly reduce water density, it would essentially turn the water above the rupture point into a foaming aerated mixture incapable of supporting flotation. A ship caught in such an event would not sink slowly, it would drop almost instantaneously into the abyss, giving crew members literally seconds to react or transmit a distress call. While direct evidence linking a triangle disappearance to a methane burst remains elusive, the final nail in the coffin for the supernatural theories is the consistent lack of any documented, validated instrument malfunction that cannot be attributed to known physical phenomena. The reported failures of compasses, radios, and engines in the historical incidents align perfectly with known issues caused by severe electrical storms, strong winds shearing antennas, water intrusion to electrical systems, or sudden and violent updrafts and downdrafts associated with tropical weather, all common phenomena in the region. The myth of the Bermuda Triangle is therefore an elaborate narrative construction built upon real tragedies and real environmental hazards, but sensationalized through the omission of critical facts and a powerful human preference for a mysterious, thrilling explanation over the harsh yet scientifically understandable indifference of nature.
The continued perpetuation of the Bermuda Triangle myth also highlights the limitations of early 20th century aviation and maritime technology, which contributed significantly to the tragic statistics later sensationalized.
Many of the most cited disappearances involve aircraft and vessels operating during periods when navigation was far more reliant on celestial positioning, radio beacons that were prone to interference, and rudimentary mechanical compasses susceptible to errors from magnetic storms or electrical issues within the craft itself. The lack of modern global positioning system, high-resolution satellite weather mapping, and reliable long-range radio systems meant that once a pilot or captain became disoriented, recovery was an incredibly difficult race against time and the elements. A simple navigational error that today would be corrected instantly by GPS could in 1945 lead a plane like those in Flight 19 far out over open water, exhausting fuel reserves and making rescue virtually impossible once the aircraft ditching occurred, particularly at night or during a sudden storm. Furthermore, the operational procedures and safety standards of the mid-20th century were vastly different. Many commercial and military flights traversing the Triangle in the 1940s and 1950s did so without the stringent emergency preparedness and robust maintenance schedules common today. In some documented cases, vessels were known to be overloaded, carrying hazardous or shifting cargo like the USS Cyclops, or operating with known, unaddressed mechanical faults. The fact that the disappearances often occurred without an immediate distress signal, Mayday, is frequently cited as evidence of a sudden, mysterious force. However, in the context of rapid, catastrophic events like a hull breach, a massive wave strike, or an explosion caused by fuel vapor or cargo instability, there would have been no time for a slow, procedural radio transmission. The crew's immediate instinct would be survival, not communication, making the silent disappearance a tragic but technically explainable outcome of swift maritime disaster. The sheer geographical nature of the Bermuda Triangle region also means it frequently sits in the path of powerful weather fronts originating both from the tropics and from continental North America, leading to a constant state of atmospheric volatility. The interaction of the warm, moist air over the Gulf Stream with colder air masses descending from the U.S. mainland often generates highly localized, intense weather phenomena known as rogue waves, unexpectedly large and steep waves that can appear suddenly even in relatively calm seas, and clear air turbulence, violent atmospheric disturbances invisible to the naked eye or early radar systems. For a plane, clear air turbulence could lead to immediate structural failure or rapid descent. For a ship, a rogue wave could swamp the vessel in seconds. The fact that these weather phenomena are inherent to the region's geography rather than being unique to the Triangle's arbitrary borders confirms that the region's danger is purely environmental and geological, not supernatural. The persistence of the myth is a powerful example of humanity's preference for a thrilling narrative that provides external blame, rather than accepting the sober reality of the ocean's indifferent, overwhelming power. The ongoing fascination with the Bermuda Triangle has also obscured the efforts of modern-day explorers and researchers who use advanced technology to systematically search for historical wreck sites within the area. Far from being an empty void, the Triangle seafloor is a vast underwater graveyard containing thousands of historical shipwrecks and aircraft losses spanning centuries, from Spanish galleons to World War II-era vessels. The difficulty, however, lies in the ocean's immense size and the rapid rate at which deep-sea currents and marine organisms break down and scatter debris. Modern sonar and remotely operated vehicles, or ROVs, are slowly unraveling the locations of several previously vanished ships and planes, often finding evidence consistent with standard causes of loss, such as severe storm damage, hull stress, or wartime actions for older losses. These slow, painstaking recoveries directly undermine the myth that the objects were transported to another dimension or vaporized by an unknown energy field. One of the more unique geological features contributing to the myth is the presence of the Florida Straits, a narrow channel within the Triangle that funnels the powerful Gulf Stream current into a very concentrated flow. This channel, combined with the often rapid fluctuation in water depth, creates exceptionally strong eddies and countercurrents that can severely challenge navigation, even for modern vessels. For smaller or older ships, getting caught in these turbulent, localized currents can lead to capsizing or severe mechanical stress. The suddenness and localized nature of these water hazards mean that a ship can go from smooth sailing to an immediate crisis without any regional weather warning, providing another realistic explanation for the sudden loss of communication often attributed to the triangle's mysterious forces. The consistent failure of recovery efforts is thus not due to supernatural intervention, but a testament to the powerful, destructive efficiency of the deep-sea environment within a highly active current system.
Furthermore, the U.S. Navy and the National Oceanic and Atmospheric Administration, NOAA, have long dismissed the supernatural theories surrounding the region, attributing the perceived danger to the cumulative effect of common hazards in a densely populated route. NOAA officially states that the area's reputation is entirely driven by anecdotal accounts and sensationalism, noting that the laws of physics are demonstrably constant throughout the triangle. The organization points to the high incidence of navigational errors exacerbated by the strong Gulf Stream, the common occurrence of localized, severe weather systems, especially rapidly developing squalls, and the deep seabed topography that swallows wreckage as the true culprits. The Bermuda Triangle, in the eyes of scientific and regulatory bodies, is merely a geographically named area where the harsh realities of the ocean are frequently encountered due to exceptionally heavy traffic, making the mystery a purely man-made construct of selective memory and media hype. The continuous flow of commercial shipping, military operations, and cruise liner traffic through the area today serves as the final, living proof that while the area requires respect for its natural challenges, it poses no unique existential threat that defies scientific understanding. The historical context surrounding the naming and popularization of the Bermuda Triangle is also crucial to understanding its lack of scientific validity. The term itself gained traction in the early 1960s, a period when global interest in the supernatural, UFOs, and ancient astronaut theories was surging. The area was effectively retroactively assigned its mysterious reputation. Incidents that had occurred decades earlier, such as the loss of the USS Cyclops in 1918, which had previously been investigated and largely attributed to weather or structural failure, were pulled from the archives and repackaged under the new, sensational headline. This historical cherry-picking allowed authors to create a statistically impressive but entirely artificial cluster of incidents spanning 50 years, thereby giving the illusion of a continuous, malevolent force. The success of these popular books cemented the myth so firmly in the public psyche that subsequent genuine accidents were immediately interpreted through the lens of the paranormal, rendering any logical explanation insufficient for public consumption. Furthermore, the specific location of the alleged triangle ensures that wreckage, even if found, often yields little definitive evidence due to the extreme environmental conditions. The combination of intense pressure at extreme depths, coupled with the high salinity and temperature variations of the water column, accelerates the corrosion and degradation of metal and organic materials. An aircraft that ditched in the 1950s, for instance, would likely be reduced to scattered, heavily corroded fragments by the time modern deep-sea technology could locate it, making forensic analysis almost impossible. This process of natural obliteration is the true author of the vanished without a trace narrative. The power of the Bermuda Triangle myth is therefore the power of negative evidence, the inability to find a definitive wreck, which is falsely interpreted as evidence for an extraordinary event, rather than evidence of the ocean's extraordinary efficiency at erasing its own history. A final analysis of the aviation aspects reveals that the Triangle region frequently falls under conditions conducive to whiteout and visual illusion, especially during low visibility conditions common in heavy fog or squalls.
When the horizon disappears, pilots can quickly lose their sense of orientation, leading to spatial disorientation, or vertigo, which can cause fatal misjudgments in altitude or speed, often resulting in controlled flight into terrain, or CFIT, and ditching. These are well-documented physiological factors in aviation accidents globally. However, when a highly experienced pilot like the commander of Flight 19 reports being utterly disoriented after experiencing compass failure, the tendency is to blame an external force rather than acknowledging the combined human factors, physiological responses, and localized environmental quirks of an extremely challenging operating environment. The Bermuda Triangle remains ultimately a compelling intersection of natural hazard, historical limitation, and psychological preference for the paranormal over the prosaic. The persistence of the Bermuda Triangle narrative also reflects a misunderstanding of historical maritime casualty rates. During the early 20th century, before modern satellite navigation, effective radar, and widespread radio communications were standardized, loss rates for transoceanic voyages were substantially higher than they are today. The triangle's notoriety stems partly from an unfair comparison of its historical accident rate from a time when global shipping was intrinsically riskier against modern safety standards. If one were to apply the same criteria of unsolved vanishings to other historically dense shipping corridors, such as the North Sea, the Strait of Malacca, or parts of the Pacific Ocean during the same era, one would find equally large clusters of mysterious losses attributable to the limitations of navigation and the ferocity of unchecked storms. The uniqueness of the Bermuda Triangle is therefore primarily a matter of branding and cultural focus, not a statistical anomaly in actual risk.
The theory regarding magnetic anomalies, though largely debunked as the sole cause of accidents, still holds a kernel of truth related to geomagneticism's effect on older systems. While the phenomenon of zero magnetic variation, where magnetic north aligns with true north, is not static or unique, the region does sit near the South Atlantic Anomaly, SAA, a region where the Earth's inner Van Allen radiation belt dips closest to the planet's surface. While the SAA is primarily an issue for satellites and spacecraft due to increased radiation, it does indicate a regional weakness in the Earth's magnetic field. While this has not been scientifically linked to the loss of ships or planes at sea level, its existence adds a subtle, scientifically true layer of magnetic oddity to the region, which readily feeds the public's desire to believe in an extraordinary, unseen force disrupting technology. This intersection of a genuine, if largely irrelevant, geophysical phenomenon with popular myth demonstrates how effectively subtle facts can be magnified into dramatic explanations. Furthermore, a significant portion of the accidents attributed to the Bermuda Triangle occurred during or immediately after World War II, a period of massive, often hurried military transport and training activity. Many of the planes and ships were military assets operating under wartime secrecy or urgency, sometimes with hastily repaired or aging equipment. In the fog of war and post-war demobilization, the documentation surrounding the loss of these military assets was often incomplete, classified, or simply lost, a bureaucratic failure often far more mundane than a dimensional warp. When investigative records fail to provide a complete public explanation, the void is immediately filled by the paranormal. The Bermuda Triangle, in this context, becomes a historical catch-all for records lost to time and bureaucracy, offering a convenient, thrilling explanation for tragic events that, were they fully documented, would likely reveal simple engineering flaws, human exhaustion, or the unpredictable nature of combat-era transport. The final truth about the triangle rests not in the unknown, but in the gaps left by inadequate historical record-keeping and the ocean's eternal capacity for destruction. The Bermuda Triangle is thus a nexus of multiple, independently operating natural hazards, strong currents, volatile weather, immense depths, and unique geology, whose combined effect is statistically certain to produce a high number of irreversible casualties over a long period, especially given the continuous, heavy traffic. The modern maritime and aviation industries no longer treat the Bermuda Triangle as a significant point of concern, which is perhaps the strongest piece of evidence against its mythological status. Contemporary risk assessments focus on verifiable threats like piracy, political instability in certain coastal areas, or known geographical choke points. The lack of any modern navigational warning issued by the International Maritime Organization, IMO, or the Federal Aviation Administration, FAA, specifically highlighting the triangle as uniquely perilous, confirms that in terms of real-world operational safety, the region is managed using standard protocols for weather, depth, and traffic density. The true danger of the Bermuda Triangle today is perhaps only to the credibility of those who continue to ignore the overwhelming scientific and statistical evidence, preferring the allure of the legend to the hard facts provided by modern satellite tracking and advanced forensic recovery techniques. The myth remains captivating, but the reality is a clear-cut story of natural geography meeting human fallibility. The final, crucial analysis of the Bermuda Triangle rests on the deliberate omission of context regarding where the incidents actually occurred. The popular narrative often treats the triangle as a homogeneous danger zone, yet many of the most famous losses happened near specific, known hazards, such as the shallow, shifting sandbanks of the Bahama Banks, or the turbulent confluence of the Gulf Stream with coastal countercurrents. For instance, the shallow reefs and constantly changing sand bottom of the Bahamas are notorious hazards for shipping, causing groundings and hull breaches that can lead to rapid sinking in unexpected locations. Attributing a ship grounded on the Bahama Banks to a mysterious force rather than a combination of poor navigation and local topography is the core mechanism by which the myth is maintained. The psychological impact of the magnetic disturbances, even if not catastrophic in a modern context, cannot be entirely dismissed in the framework of the myth's origins. In the pre-GPS era, experiencing unexpected behavior from a primary compass was deeply unsettling for navigators. This sudden, inexplicable loss of the one reliable guide in the vastness of the sea would induce panic and lead to flawed decision-making, especially when combined with darkness or storm conditions. The triangle's reputation became a self-fulfilling prophecy. Sailors entered the region already primed by the myth to fear instrument failure, potentially leading to overreactions or an immediate abandonment of standard operating procedures when a minor fault occurred. This interplay between mythological expectation and human reaction amplified the risk, transforming correctable technical glitches into irreversible human catastrophes. The entire lore of the Bermuda Triangle ultimately serves as an unparalleled example of how pseudoscience leverages natural phenomena. Authors and theorists selectively use terms like magnetic anomaly, methane hydrate, and clear air turbulence to sound authoritative. Yet they divorce these real-world events from their scientific probabilities and contexts, instead framing them as manifestations of a singular, inexplicable external power. The real evidence consistently demonstrates that every disappearance, when stripped of the dramatic narrative layers and subjected to forensic and statistical scrutiny, falls within the expected parameters for maritime and aviation losses in a dynamic, high-traffic region. The lasting legacy of the Bermuda Triangle is not as a geographical mystery, but as a fascinating and enduring cultural artifact,
demonstrating humanity's relentless quest to find pattern and purpose in the random, indifferent tragedies inflicted by the ocean's unyielding majesty.
The relentless cycle of sensationalism surrounding the Bermuda Triangle often glosses over the fundamental reality of marine salvage and wreck recognition. The deep ocean environment ensures that large wreckage fields often disintegrate within decades, particularly in the high oxygenated waters of the upper abyssal plain. What remains are scattered pieces of metal, plastic, or ceramic, often unrecognizable as part of a once mighty ship or aircraft. This rapid breakdown, coupled with the immense cost and technical difficulty of deep-sea exploration, which can often exceed the value of the wreck itself, means that a vast majority of oceanic losses remain officially unsolved globally, not because of a mysterious force, but due to economic and logistical constraints. The Triangle's unique notoriety comes simply from being the only oceanic graveyard where the inability to find evidence is culturally celebrated as proof of a paranormal event, a powerful testament to the triumph of thrilling storytelling over tedious forensic investigation. This psychological environment gave rise to countless fictionalized accounts, blurring the line between fact and legend. Consider the narrative surrounding the Carpathia's second journey, a fictitious yet widely shared tale from the 1930s that captures the exact paranoia the Triangle embodies. The Carpathia, famous for rescuing survivors of the Titanic, was itself sunk by a U-boat in 1918 outside the Triangle, but the legend relocated the sinking. This apocryphal story claims that in 1937, a smaller freighter, the SS Ilara, vanished mid-transmission while carrying a cargo of rare scientific instruments through the Triangle. The final radio message, allegedly intercepted by a confused operator in Key West, was not a distress call, but a fragmented, terrified whisper. "It's gone! The water is turning inward! The sky is liquid! We are seeing the colors of the—" The transmission then cut out abruptly, followed only by static. While the ship Ilara and the transmission are entirely invented, the story's resonance is immense because it perfectly combines the key elements of the Triangle myth: the sudden, unexplained silence, the implication of a dimensional shift or physical impossibility, and the terrifying fragmented communication. The tale serves as a powerful illustration of the emotional truth the Triangle represents: the sudden, incomprehensible surrender to an unseen, chaotic cosmic force. This vivid fictional color, repeated across generations of popular accounts, does far more to sustain the legend than any factual analysis of methane hydrates or compass variations ever could. The fear is not of a storm, but of the unmaking of reality suggested by tales like the Carpathia's second journey. The actual evidence, patiently compiled by hydrographers and accident investigators, suggests a far less cinematic but ultimately more important conclusion. The Bermuda Triangle is a zone of heightened risk simply because its geography forces together multiple severe natural hazards: the unpredictable volatility of the Gulf Stream, the navigational challenges of the Florida Straits, and the frequent violent weather patterns, all compounded by the sheer volume of human error and mechanical failure in one of the world's most heavily utilized marine superhighways. The final sober truth is that the region's notoriety is a historical accident, a confluence of tragic timing and evocative journalism, proving that the human appetite for an extraordinary mystery is often far greater than the appetite for a mundane statistical explanation of disaster. The Triangle is a mirror reflecting our fear of the unknown, giving a name and a place to the inevitable, chaotic power of the deep ocean. The enduring fascination with the Bermuda Triangle also serves as a critical example of how cognitive biases, particularly the availability heuristic, skew public perception of risk. Because dramatic, unexplained disappearances are highly memorable and widely publicized through books, documentaries, and the internet, the public overestimates the probability of such an event occurring in that specific location, while simultaneously underestimating the far greater but less sensational risks posed by common factors like fatigue, inadequate maintenance, or sudden structural failure in other ocean zones.
The constant reinforcement of the legend makes every minor incident within the triangle's borders appear statistically significant, when in reality, a simple actuarial analysis by marine insurance entities confirms that the risk of loss per vessel mile traveled is entirely consistent with high-traffic regions like the English Channel or the South China Sea.
The perception of an unusual danger is thus maintained not by a mysterious physical force, but by the relentless cultural force of storytelling and selective memory, which consistently prioritizes the thrilling narrative of the vanishing over the dull reality of statistical normalcy. The continued popularity of the myth highlights a deep-seated human resistance to accepting that catastrophic events can occur randomly and without a discernible external malevolent cause. The lack of political or scientific consensus on the triangle's exact boundaries further underscores its fictional nature. Different authors and researchers have proposed wildly different coordinates, sometimes encompassing the entire Gulf of Mexico or extending far into the mid-Atlantic, depending on which historical shipwrecks they wish to include in their statistical count of vanishings. This fluid geography is a powerful indicator that the triangle is a concept defined by the data it seeks to explain, rather than a genuine, physically distinct zone of anomaly. If the danger were tied to a true geological or magnetic singularity, its borders would be fixed and definable by geophysical parameters. Instead, the ever-shifting map of the Bermuda Triangle is the ultimate proof that its existence relies solely on the narrative convenience of grouping geographically disparate and historically unrelated tragedies together to sustain the illusion of a singular, recurring threat. The real evidence, therefore, is the map itself. A map drawn not by cartographers or scientists, but by authors seeking to sell a captivating mystery. Furthermore, an often overlooked factor in the myth's inception is the historical role of Cuban and Haitian political instability in the mid-20th century. During periods of conflict and high tension, ships and small planes operating in the southern portions of the alleged triangle could have been lost due to undocumented military action, piracy, or political confiscation, with their disappearance subsequently blamed on the triangle's curse to avoid diplomatic complications or uncomfortable investigations. These human, terrestrial threats offer a non-supernatural explanation for the rapid, silent disappearance of certain vessels, especially during the Cold War era, when military activities were often highly secretive. The mystery of the Bermuda Triangle thus functions partly as a historical veil, concealing potentially embarrassing or politically sensitive incidents behind the convenient, sensationalized cover of an uncontrollable atmospheric or oceanic force, demonstrating how the myth not only obscures environmental facts, but also complicated political realities. The fascination with the Bermuda Triangle ultimately transcends the quest for scientific truth, cementing its place as an indelible modern legend. It is a geographical location that has successfully absorbed global anxieties about technology, the unforgiving nature of the deep ocean, and the randomness of fate. The triangle's greatest power lies not in its ability to destroy ships, but in its unparalleled ability to destroy human confidence in predictability, forcing us to confront the enduring, terrifying possibility that even with all our satellites and sonar, there remain vast, deep corners of the world where order gives way to the abyss. The statistical fallacy at the heart of the Bermuda Triangle narrative can be rigorously demonstrated by overlaying global maritime traffic data onto a map of major shipping losses.
When accounting for the immense volume of commercial and recreational traffic that traverses the region daily, connecting the crucial ports of the eastern United States, the Caribbean, and Europe, the percentage of lost vessels and aircraft per million voyages is entirely unremarkable. If the same methodology used to define the triangle, clustering all unexplained or poorly documented losses over a century, were applied to the area of the Mediterranean Sea between Sicily, Malta, and the coasts of North Africa, a comparable, if not greater number of historically unsolved sinkings would be found, attributable to piracy, wartime action, overcrowded traffic, and sudden squalls. Yet this region holds no popular mythological status. This discrepancy underscores that the triangle's danger is purely narrative-driven, fueled by the evocative name and the cultural impact of early sensationalist writers who chose this particular geography for their focused, selective compilation of tragedies, effectively creating a modern constellation of disaster out of random events.
The scientific community's dismissal of the supernatural theories is based on the consistent failure to detect any known physical force capable of instantaneously vaporizing large masses of metal and wood or teleporting them across dimensions. Theories involving magnetic fields, gravitational singularities, or electromagnetic disturbances lack any measurable, sustained physical evidence in the region that could account for the observed losses. While localized electromagnetic interference, EMI, can be caused by severe thunderstorms, known as sprites or blue jets, these phenomena are short-lived and, while capable of temporarily disrupting radio or compass readings, are not known to possess the energy required for the simultaneous, catastrophic structural failure of multiple vessels. The persistence of the supernatural theories, therefore, requires a continuous disregard for the law of conservation of mass and energy, necessitating belief in a power that functions entirely outside the observable universe, a stance that renders the mystery fundamentally immune to scientific resolution, sustaining its status in the realm of faith rather than fact. Furthermore, the complexity of ocean currents beyond the main Gulf Stream current must be considered. The region is characterized by mesoscale eddies, large rotating masses of water that spin off the main current, which create chaotic, localized, turbulent zones. These eddies can cause sudden, powerful vertical mixing of the water column, leading to unanticipated water movements that can rapidly shift sandbanks, induce severe structural stress on hulls, or rapidly pull small debris down into the depths. This hydrodynamic complexity, a natural consequence of the clash between fast currents and deep trenches, provides a nuanced and scientifically robust explanation for the sudden onset of peril that characterizes many triangle disappearances. The reality is that the region demands extremely skillful seamanship and unwavering attention to local conditions, as the ocean's behavior changes not over miles, but often over mere hundreds of yards. The triangle is thus a brutal, unforgiving examination room for maritime skill, where the slightest lapse in judgment or vigilance is efficiently punished by powerful natural forces, confirming that the tragedy lies in human vulnerability, not supernatural intervention. The modern-day safety record of the Bermuda Triangle provides the most compelling evidence against the enduring mythology. If the area truly harbored a localized, sustained physical anomaly capable of defying physics, a dimensional portal, a permanent magnetic vortex, or an underwater crystal firing death rays, the sheer volume of modern aviation and shipping traffic would guarantee daily incidents. Cruise ships, commercial freighters, and thousands of private aircraft transit the designated area constantly, utilizing GPS and modern inertial navigation systems, INS, that are entirely immune to the magnetic compass errors that plagued earlier vessels. The absence of a corresponding surge in catastrophic, instantaneous losses in the last half-century, despite this massive increase in traffic, fundamentally debunks the notion of a unique, active threat. The reality is that modern technology has effectively neutralized the environmental factors, navigational disorientation and unpredictable weather, that contributed to the majority of the historical mysteries, confirming that the problem was always one of human technological limitation against powerful natural forces, not a failure of the laws of physics themselves.
Furthermore, the environmental impact of the triangle's topography extends to the atmosphere, contributing to atmospheric turbulence and volatility. The extreme thermal contrast between the cold depths of the trenches, the warm surface waters heated by the Gulf Stream, and the rapidly moving air masses generates frequent and unpredictable pockets of severe wind shear and microbursts. A microburst, a localized column of sinking air within a thunderstorm that can produce damaging straight-line winds, can hit a small aircraft with the force of a bomb, causing immediate and catastrophic structural failure before the pilot can transmit a signal. These highly localized, fast-forming weather events are a known hazard of the maritime continental interface, and their frequent occurrence in the triangle provides a plausible, non-supernatural explanation for the instantaneous loss of several aircraft, particularly those operating during the early days of flight when meteorological forecasting was rudimentary and aircraft were structurally less robust against extreme stress. The Bermuda Triangle's danger is, therefore, a predictable consequence of its unstable thermal and atmospheric gradients, not a mythical curse. The final component sustaining the mystique is the cultural and cinematic portrayal of the area. The enduring mystery has proven to be an exceptionally valuable asset to the tourism and entertainment industries, which have a vested interest in keeping the legend alive. Documentary programs often give equal weight to speculative supernatural claims and sober scientific analysis, effectively validating the wildest theories by placing them alongside factual data. This economic incentive to maintain the allure ensures that the myth continues to be promoted, often overshadowing the efforts of groups like NOAA and the Coast Guard to educate the public on the real, manageable risks of the region. The Bermuda Triangle has transcended geography. It is now a cultural franchise, where the thrilling narrative of the unknown generates more tangible profit than the mundane reality of the ocean's indifference, making the legend far more powerful and persistent than the actual evidence of peril. The lack of critical geographical context in the Bermuda Triangle narratives often ignores the vast continuous shelf of shallow water, the Great Bahama Bank, that covers a massive portion of the supposed triangle area. While some areas plummet to abyssal depths, much of the region is characterized by water that is startlingly shallow, often less than 20 to 30 feet deep. This shallow topography presents an immense and unique hazard. Strong currents can rapidly shift the soft sand bottom, opening temporary channels or suddenly creating obstacles where none existed hours before. A vessel traversing these banks, even slightly off course due to compass error or poor visibility, risks immediate and violent grounding. A high-speed grounding in the shallow water can breach a hull instantly, leading to a rapid sinking, yet the shallow depth makes the scattered wreckage incredibly difficult to detect from the surface due to the turbulence and the vast expanse of the banks, contributing another unique geographical factor to the no-trace mystery that is entirely non-supernatural.
Furthermore, the concentration of wartime losses in the historical record artificially inflates the triangle's casualty count. During World War I, and particularly World War II, the entire North Atlantic was a dangerous war zone, heavily patrolled by U-boats and subject to mine warfare. Numerous losses cited in the Bermuda Triangle myth, including wartime vessels and their escorting aircraft, were likely the victims of unreported or unconfirmed U-boat attacks, mines, or friendly fire accidents that were either never officially investigated or whose records were classified during the Cold War era.
Blaming these losses on a mysterious force avoids the more complicated historical realities of oceanic conflict and espionage, serving to sanitize the historical record. This transference of blame highlights how the Bermuda Triangle myth functions as an historical narrative of convenience, substituting a sensational atmospheric explanation for a complex, politically sensitive terrestrial reality, allowing the myth to absorb the fatalities of combat and operational failures into its roster of the unexplained. The final conclusion, repeatedly drawn by expert panels and official maritime authorities, is that the Bermuda Triangle myth is a fascinating, powerful example of perceived risk outweighing actual risk. It is a geographical area where all the natural challenges of seafaring, deep trenches, powerful currents, rapidly changing weather, and treacherous shallow waters converge in a high-traffic environment. The real evidence demonstrates that every disappearance, when properly investigated and contextualized within the technological limitations and environmental realities of its time, points to clear, understandable mechanisms of loss: mechanical failure, navigational error, or the brute force of nature. The enduring mystery, therefore, is not a failure of physics, but a brilliant, highly successful failure of narrative clarity, where the thrill of the unknown perpetually triumphs over the simple yet sobering facts of oceanic reality.
Furthermore, a specific, highly localized hazard, often overlooked in the sensationalized accounts, is the presence of underwater volcanoes and hydrothermal vents along the edges of the Puerto Rico Trench and the associated fault lines. While these are not active in a way that would sink a ship, they introduce localized thermal and chemical variations into the water column. These localized phenomena can potentially cause sporadic, temporary disruptions to highly sensitive magnetic sensors or acoustic equipment used by submarines and research vessels, adding subtle, scientifically verifiable oddities to the region that are then magnified by the myth. The Bermuda Triangle, therefore, is a place where even genuine minor geophysical curiosities are immediately absorbed and reinterpreted as evidence of a massive, inexplicable threat, demonstrating the constant process of mythological incorporation that sustains the legend. The complexity of the Earth's processes in this region is the true non-supernatural source of the environmental chaos attributed to the Devil's Triangle. In final summation, the Bermuda Triangle functions as a cultural barometer for the limits of human control and knowledge. It is a designated space where we acknowledge, albeit reluctantly and through the filter of sensationalism, that nature's complexity and power still far exceed our technological mastery and capacity for recovery. The statistical evidence, the forensic analysis, and the testimonies of modern mariners confirm that the mystery is entirely a product of the human narrative. The area is not devoid of peril, but its risk is manageable and understandable, rooted firmly in the laws of physics and the harsh realities of the ocean environment. The enduring popularity of the Bermuda Triangle is not a reflection of its unique danger, but rather a profound reflection of humanity's timeless fascination with the unknown and the tragic power of a good story.
Furthermore, the geological study of the area also reveals the instability of the seabed along the continental shelf break, where the shallow shelf abruptly drops off into the deep abyssal plain. This area is highly susceptible to underwater landslides and turbidity currents, dense sediment-laden flows of water that rush down the continental slope. These currents are powerful enough to carry away massive amounts of wreckage and sediment, burying objects instantly or scattering them over vast, inaccessible areas of the deep trenches. A ship sinking near this shelf break might be caught in such a current, resulting in its rapid disappearance from the expected search area and its ultimate burial under tons of seafloor sediment. This geological volatility provides yet another natural, non-supernatural explanation for the complete, final loss of evidence, emphasizing that the ocean's own subsurface dynamics are highly efficient at preserving the illusion of the supernatural disappearance that fuels the triangle's terrifying legend. The final undeniable proof that the Bermuda Triangle is a constructed myth is the simple fact that the organizations responsible for maritime and aviation safety do not acknowledge its existence as a unique threat. No pilot or captain filing a flight plan or manifest is required to take special, extraordinary precautions beyond those standard for flying over or sailing through a high-traffic, geographically challenging oceanic region. If the threat were real, the FAA and IMO would be legally and ethically obligated to issue unique hazard warnings, establish restricted zones, or mandate specialized equipment, none of which have ever been put into place. The failure of the triangle to generate any actual, formal regulatory response is the clearest indication that the perceived peril is confined entirely to the realm of fiction and sensationalized history, while the factual risk is handled daily by competent professional navigators and sophisticated modern technology. The psychological anchoring that underpins the Bermuda Triangle myth is deeply tied to the human tendency toward apophenia, the experience of seeing meaningful patterns or connections in random or meaningless data. When a cluster of random maritime and aviation accidents occurs across a large geographical expanse over many decades, the human brain instinctively seeks a singular unifying cause, rather than accepting the complex reality of multiple unrelated environmental and human factors. The triangle serves as the designated unifying pattern for these random disasters, offering a simple, satisfying narrative closure that the true, messy forensic records involving failing gaskets, exhausted pilots, unforecast squalls, and shifting compass deviations simply cannot provide. This mental shorthand allows the mystery to persist because it simplifies chaos, transforming a series of unlucky, disparate events into evidence of a malevolent design, making the legend far more compelling than the prosaic truth of statistical variance and environmental volatility. A critical yet often neglected aspect of the area's risk profile is the impact of acoustic and sonar interference. The complex bathymetry, the rapid shifts from shallow shelf to the Puerto Rico Trench, creates highly unpredictable conditions for sound waves in the water column. These variations caused by thermal layers and pressure changes can produce localized sonar shadow zones or distort acoustic signals, making it extremely difficult for search and rescue vessels to locate downed aircraft or sunken vessels using underwater acoustic equipment. This technological limitation, rooted in the genuine geophysical characteristics of the triangle, further contributes to the vanished without a trace narrative. The failure to locate wreckage is thus a function of hydroacoustic physics, not paranormal activity, underscoring the point that the unique challenges of the Bermuda Triangle are indeed real, but they are entirely natural and explainable. The final lasting cultural impact of the Bermuda Triangle is its function as a modern urban legend. Like myths of the Kraken or phantom ships of old, the Triangle serves a crucial societal role by codifying and containing our collective fears about nature's untamable power. It provides a specific named location onto which we can project our anxieties about technological failure, the limits of rescue capabilities, and the finality of death at sea. In this sense, the Triangle is less about geography and more about collective psychology, a designated place on the map where the rational mind permits itself to entertain the possibility of the impossible. The continued need to tell and hear these stories ensures that the legend will survive indefinitely, long after technology has rendered the historical navigational hazards entirely obsolete. The lack of consistent depth across the Bermuda Triangle is a geographical factor whose relevance is frequently obscured by the focus on the abyssal trenches. The area includes numerous underwater caves, coral reefs, and sudden vertical rot formations, particularly around the islands of the Bahamas and Bermuda. These shallow hazards are not static. The powerful currents can rapidly shift sand, exposing jagged rock or creating unpredictable turbulence. A vessel that might successfully navigate a passage one day could find itself instantly grounded or capsized the next due to the sudden exposure of a rocky outcrop or the formation of a localized severe rip current. The speed and unexpectedness of these shallow water threats provide yet another non-supernatural mechanism for rapid catastrophic loss near coastlines, which, when aggregated with the deep water losses, creates the statistical illusion of a unified mysterious threat. This environmental reality confirms that the Triangle's danger is not monolithic, but a combination of diverse, localized, and dynamic natural hazards that punish navigational error across its entire depth spectrum. Furthermore, the analysis of communication failures, often cited as proof of electromagnetic anomalies, typically fails to account for the limitations of early radio technology, particularly in a tropical environment. In the mid-20th century, high-frequency HF radio communications were highly susceptible to atmospheric interference caused by electrical storms, solar flares, and the massive amounts of static electricity generated by humid air and intense convection, thunderstorms. A sudden, localized severe weather event could easily cause a complete radio blackout, making distress calls impossible to transmit or receive, leading to the terrifying mid-sentence cutoff phenomenon common in the lore. This communication silence is therefore a predictable consequence of the region's volatile tropical meteorology interacting with outdated technology, rather than evidence of a spatial or temporal vortex. The ability of nature to instantaneously sever contact provides a powerful, realistic source for the fear of being swallowed by the unknown.
The persistence of the Bermuda Triangle myth ultimately represents a triumph of cultural memory over empirical data. Despite consistent debunking by official sources, the narrative of the mysterious void holds a unique, enduring appeal because it confronts humanity's greatest fear, being erased without reason or trace. The Triangle provides a satisfying, albeit fictional, explanation for the arbitrary nature of tragedy. It is the designated location where fate, personified by an invisible force, is allowed to cheat, taking lives without adherence to the usual rules of probability or cause and effect. This function as a cultural repository of existential anxiety ensures that the Bermuda Triangle remains one of the world's most enduring and captivating geographical fictions. The psychological anchoring provided by the Triangle's narrative also inadvertently masks the reality of piracy and illicit activity, particularly concerning losses in the mid-20th century. During periods of geopolitical tension and economic instability in the Caribbean, several smaller cargo vessels and private yachts may have been lost not to weather or supernatural forces, but to acts of piracy or maritime crime, with the perpetrators intentionally sinking the vessel after looting it to ensure no evidence remained. Blaming such disappearances on the Triangle offered a convenient way for authorities or insurance companies to close cases without launching costly and politically sensitive international investigations into criminal networks operating in the contested waters of the Bahamas and the Florida Straits. The silence surrounding these potential crimes was therefore not the result of an ethereal force, but a function of criminal concealment and geopolitical expediency, adding a layer of tragic human malice to the myth's foundation that is rarely acknowledged by the sensationalist narratives. Furthermore, the environmental risk is compounded by the sheer thermal energy stored in the surface waters of the Triangle, driven by the intense tropical sun and the continuous flow of the Gulf Stream. This thermal energy fuels the intensity and rapid development of all manner of severe weather systems, from the aforementioned microbursts to the full fury of Category 5 hurricanes. The environment is highly reactive, A small atmospheric disturbance can escalate into a life-threatening storm far faster in this energy-rich zone than it would in colder, less dynamic waters. This high degree of meteorological volatility ensures that the area remains inherently dangerous, confirming that the incidents are not random but are highly correlated with the region's intense thermal and hydrological characteristics. The Bermuda Triangle is, quite simply, an area where natural chaos is amplified by massive energy reserves. The persistent myth also overshadows the immense historical and ecological value of the Triangle region. Far from being a barren void, the seafloor is a rich repository of history, holding the wrecks of colonial-era ships, treasures, and artifacts that predate the modern myth by centuries. Moreover, the area encompasses a critical marine biodiversity hotspot, sustained by the Gulf Stream and the very depths of the coral reefs and deep trenches. By constantly focusing public attention on these supernatural disappearances, the narrative inadvertently distracts from the vital work of marine archaeologists and environmental conservationists who are actively working to study and protect this complex, scientifically fascinating, and historically rich body of water. The true legacy of the Bermuda Triangle should shift from a focus on fabricated fear to one of factual wonder and crucial environmental stewardship.
The terrifying secret of the Bermuda Triangle is that there is no secret at all. It is the place where the map ends and the human story begins.